So what you're seeing here is a mouse watching a movie, and what we want to be able to do is to reconstruct what that animal is seeing, and that's exactly what we could do with our new deep learning algorithm called Zebra. Zebra allows us to take neural data from the brain, the visual cortex of these mice, and train a deep learning model that allows us to then decode what the animal is actually watching. So roughly 10 years ago, we were at the point where we could decode very simple shapes from the brains of animals or humans. But now we're at the point where we can decode literally movie frames, which has never been done before. So when humans, or even mice, watch this movie, what is happening is that millions of neurons in their brain is firing in response to the different properties of this video, whether it's the objects, the color, the texture, or even the emotions that are invoked when you in watching and understanding this. And so what we need to be able to do is, given we can only record from a small part of the brain at any one given time, is to build this deep learning model that actually represents all of these abstract spaces, these so-called hidden latent dynamics in the brain. We used open source data that was collected from the brains of mice using electrophysiological signals or new technology called two-photon calcium imaging. That literally means that these mice are genetically engineered, that every time the neuron fires or transmits information, they glow green, so we can truly just record them from the outside with a camera. So we can take these genetically engineered mice and record from their brain while they watch these movies. You can do this for many mice and use that as training data to train the base algorithm in Zebra. Then you can take a new mouse whose neural data we've never seen, run this through the algorithm, and it can then predict which frame the mouse is actually watching of this movie. Concretely, what we did is we modified the loss function of an algorithm called contrastive learning. And what this now allows us to do is to sample from both discrete and continuous data streams to build this representation space. Zebra takes neural data and the behavioral data of the animal and jointly learns this representational embedding space.
So here we have an example of a rat moving up and down a linear track, and we record neural activity from hippocampus. And in this example, we shape the embedding space with the position information that we have available and find an embedding space that is highly accurate at decoding the position of the rat.
Zebra, of course, doesn't have to be just about decoding the brain state for movie watching, but actually can be generalized to completely other domains.